5 ancient technologies. So advanced, they still make modern scientists stop and ask the same question. How did they do it? Number 5. Survived for nearly 2,000 years. Number 4. Solved a problem modern engineers are still trying to solve today. Number 3. Was a machine built with technology that shouldn't have existed for its time. Number 2. Was a weapon so terrifying its exact formula disappeared from history. But number 1 is something completely different, because it wasn't just advanced for the ancient world. It was so far ahead of its time that even today, we still haven't fully explained how it was made. And once you discover what it was, you may never look at ancient civilizations the same way again. These are 5 ancient technologies that still challenge what we think the past was capable of. And we're starting with number 5, a material that may have been able to literally repair itself for nearly 2,000 years. One enormous structure has survived earthquakes, fires, wars, and the collapse of entire empires. Its massive concrete dome still stands. The builders who created it had no computers, no modern laboratories, no steel reinforcement, and yet their concrete may have possessed something modern concrete still struggles to achieve: the ability to heal itself. Scientists have spent decades studying Roman concrete, and the deeper they look, the stranger it becomes. Modern concrete is incredibly strong, but it has a weakness. Over time, tiny cracks appear. Water enters, steel reinforcement begins to rust, and eventually, the structure needs expensive repairs. The ancient Romans faced the same forces. Yet, some Roman concrete structures have survived for nearly 2,000 years, especially in harbors, where waves and seawater have attacked them for centuries. And in some cases, the concrete appears to become stronger with age. For years, scientists believed volcanic ash was the main secret. The Romans mixed volcanic material from around Mount Vesuvius with lime and stone. The result was an incredibly durable material. But then, researchers noticed something unusual: tiny white fragments scattered throughout the concrete. At first, they were dismissed as imperfections, poor mixing, careless workmanship. But when scientists examined them more closely, they discovered something surprising. The fragments were made of lime, and they may have been the key to Roman concrete's extraordinary durability. The Romans may have used a technique known as hot mixing, working with highly reactive lime during the concrete making process. Later, when cracks formed, water could reach those lime fragments. A chemical reaction would begin. New minerals formed inside the cracks, helping seal them. In other words, the concrete may have been repairing itself, a form of self-healing construction created almost 2,000 years ago. Today, researchers are studying these ancient principles to develop longer-lasting modern concrete, buildings that require fewer repairs, infrastructure that lasts longer, and potentially a future with less construction waste. But Roman concrete raises a much bigger question: how many other ancient technologies have we misunderstood? Because the Romans weren't the only civilization to create something far ahead of its time. And number 4 will take us far away from ancient Rome, because the next technology wasn't designed to build massive structures. It was designed to structures. It was designed to solve a problem that modern engineers are still struggling with today. And what makes it even more remarkable is that ancient engineers may have solved it thousands of years ago. This is number 4. And the problem was water. For ancient civilizations, Getting enough fresh water was one of the greatest challenges imaginable. Cities were growing, populations were increasing, and people needed water. Not just for drinking, but for bathing, for farming, for public fountains, and for keeping entire cities alive. Today, we can move water almost anywhere. We use electric pumps, powerful engines, computer-controlled systems, but thousands of years ago, ancient engineers had none of that. So they found another solution. They used something far simpler: gravity. The technology was the aqueduct, and the ancient Romans turned it into an engineering masterpiece. Roman aqueducts carried fresh water across enormous distances. Some traveled underground, others crossed valleys, on massive stone arches. And the incredible part was that many of them didn't need pumps. The water simply flowed, because the entire system was designed with an incredibly precise slope. Too steep, and the water would move too quickly. Too shallow, and the water would stop flowing. The engineers had to calculate the landscape, the distance, the elevation, and the angle with astonishing precision. And they did it without satellites, without GPS, without modern surveying equipment. They used mathematics, simple measuring instruments, and generations of engineering knowledge. Some Roman aqueducts carried water for dozens of miles. They supplied entire cities with a steady flow of fresh water, and this changed everything. Cities could grow larger. Public baths became possible. Fountains appeared in city centers, and clean water could reach places where natural sources were nowhere nearby. But aqueducts weren't just about convenience. They were about power. The ability to control water allowed Rome to control cities. It helped armies survive. It supported growing populations, and it allowed an empire to expand across enormous distances. But here's what makes the technology even more impressive. The Romans weren't simply building bridges to carry water. They were creating an entire system: tunnels, channels, pipes, settling tanks, and enormous arches, all working together. And the system had to function for years, sometimes for centuries. Some ancient aqueducts are still standing today, but there was a problem that even the Romans couldn't completely solve. Water carries minerals. Over time, those minerals built up inside the channels, slowly narrowing the passageways. Eventually, the aqueducts needed maintenance. The Romans had to clean them, repair them, and keep the water flowing. And yet, the basic principle still works: gravity, precision, and engineering. A solution created thousands of years ago still influences how we think about moving water today. But number 4 wasn't the only ancient technology that solved a problem modern engineers still face. Because our next discovery, it is something completely different. It wasn't designed to move water. It was designed to understand the universe. And when scientists finally discovered it, they found something that seemed impossible: a machine with dozens of tiny gears that could model the movements of the moon, predict eclipses, and track the cycles of the heavens. The strangest part is that it was built more than 2,000 years ago. This is number 3. More than 2,000 years ago, someone built a machine that could calculate the movements of the heavens. The story begins in 1901. Divers exploring an ancient shipwreck near the Greek island of Antikythera discovered something extraordinary. Among statues, coins, and ancient treasures, they found a strange lump of corroded bronze. At first, it looked almost worthless, just another piece of wreckage, lost beneath the sea. But then, researchers noticed something unusual: tiny gears, dozens of them. And suddenly, the discovery became something completely different. This wasn't a simple tool. It was a machine. As scientists began studying the fragments, they discovered something astonishing. The device could track astronomical cycles. It could follow the movement of the moon, predict eclipses, and calculate celestial events, all through an intricate system of interlocking gears. Remember, this machine was created more than 2,000 years ago, long before mechanical clocks, long before precision engineering, and long before computers. The technology was so sophisticated that scientists spent decades trying to understand how it worked. Then, advanced X-ray imaging allowed researchers to look inside the corroded fragments hidden beneath the surface were gears, engravings, and evidence of an incredibly complex astronomical system. The machine became known as the Antikythera mechanism. And it wasn't simply measuring time. It was modeling the heavens, a mechanical representation of how ancient Greeks understood the universe around them. But here's where the mystery gets even deeper. The machine we discovered was probably not the first of its kind. Someone had to invent the design. Someone had to understand the mathematics. Someone had to build the gears. And someone had to teach others how to create machines like it. Which means the Antikythera mechanism might have been the surviving piece of an entire technological tradition that eventually disappeared. And that's what makes this discovery so important. Technology doesn't always move forward in a straight line. Sometimes civilizations develop extraordinary knowledge. And then the Antikythera mechanism proves that ancient engineers were capable of far more sophisticated technology than we once believed. But if they could build a machine that modeled the movement of the stars, what else were they capable of? Because number 2 is something far more dangerous. It wasn't designed to study the heavens. It was designed for war, a weapon so terrifying that enemies described flames spreading across the surface of the sea. And the most incredible part is that its exact formula has been lost for more than 1,000 years. This is number 2. For centuries, the Byzantine Empire possessed a weapon that terrified its enemies. It wasn't a sword. It wasn't a catapult. And it wasn't ordinary fire. According to historical accounts, this weapon could burn on water. And when Byzantine forces unleashed it against enemy ships, the results were devastating. Flames spread across the surface of the sea. Wooden ships caught fire. Sailors panicked. And suddenly, the water itself seemed to become part of the attack. The weapon became known as Greek fire, and the Byzantines guarded its secret with extraordinary care. The exact formula was never openly revealed. The knowledge was closely protected, passed through a limited number of hands, and treated like a military secret. That secrecy made the weapon even more terrifying. Enemies didn't know exactly what they were facing. They only knew that once the flames reached their ships, escape could become almost impossible. But Greek fire wasn't magic. It was chemistry. And that's where the mystery begins. Historians have proposed many possible ingredients: petroleum, naphtha, resins, sulfur, quicklime, perhaps a combination of several substances. But the exact recipe is gone. And even if we knew every ingredient, we would still need to know exactly how the Byzantines prepared it, how they stored it, and how they launched it toward enemy ships. The technology wasn't just a chemical mixture. It was an entire system, a secret formula, a method of production, specialized equipment, and a way to use it in naval warfare. Then, the Byzantine Empire began to decline. Wars changed. Cities fell. And eventually, the knowledge disappeared. A weapon that once helped defend one of the greatest cities in the world vanished into history. Modern scientists can create substances that burn on water, but recreating something similar isn't the same as proving exactly how Greek fire worked. And that's why, more than 1,000 years later, the mystery remains. We know the weapon existed. We know it was terrifying. We know it changed battles, but the technology behind it remains one of history's greatest chemical mysteries. And Greek fire reveals something even more important. Sometimes, the greatest inventions don't disappear because they were impossible to build. They disappear because the people who knew how to build them are gone. But now, we've reached number 1, and the final technology is different from everything we've seen so far. It isn't simply an ancient invention that modern scientists find impressive. It may be the most mysterious technology on this entire list, because despite everything, modern science still cannot fully explain exactly how the ancient builders achieved it. And what makes it even stranger is that the evidence is still standing today. This is number 1, and unlike the other technologies, this one is still standing, not in a museum, not at the bottom of the ocean, but across an ancient landscape, where its secrets have survived for thousands of years. The technology is the ancient Egyptian stone cutting technique. The Egyptians built enormous monuments using blocks of stone that weighed several tons. Some were transported across enormous distances. Others were shaped with astonishing precision, and that's where the mystery begins. Because some ancient stone surfaces are remarkably smooth, some blocks fit together with incredibly tight joints, and some structures were built with an accuracy that still surprises engineers today. The ancient Egyptians didn't have modern power tools. They didn't have diamond saws. They didn't have electric drills. They didn't have cranes or computer-controlled machines. And yet, they worked with some of the hardest stones on Earth: granite, quartzite, and other extremely durable materials. So how did they do it? Archaeologists have discovered ancient copper tools, stone hammers, abrasive materials, and evidence of techniques that could explain much of the process. But the exact methods used for the most difficult cuts and the most precise work are still debated. The Egyptians may have used copper tools together with abrasive sand, hard stone pounders, to shape the surface, and carefully controlled techniques passed from one generation to the next. But here's the fascinating part. The question isn't whether ancient Egyptians were capable of building great monuments. They clearly were. The question is, how much of their technical knowledge have we lost? Because building something enormous is one challenge. Building it with extraordinary precision is another. And this is where our 5 technologies come together. Roman aqueducts showed us that ancient engineers could move water across enormous distances using nothing but gravity and precision. The Antikythera mechanism showed us that ancient engineers could build complex machines capable of modeling the heavens. Greek fire showed us that ancient civilizations could develop sophisticated chemical technologies and protect their secrets for generations. And ancient Egyptian stonework reminds us that the past may still contain engineering techniques we don't fully understand, but perhaps that's the greatest lesson these technologies can teach us. The ancient world wasn't more advanced than ours. Modern science has achieved things the ancient world could never have imagined. But progress isn't always a straight line. Knowledge can disappear. Civilizations can collapse. Craftsmen can die. And when the people who understand a technology are gone, the technology can vanish with them. Sometimes, all that remains is a strange machine, a mysterious weapon, an ancient structure, or a perfectly cut piece of stone. Clues, without instructions, evidence, without an owner, and perhaps that's why ancient technology still fascinates us, because every discovery raises another question. What else did they know? Ooh, what else have we forgotten? And what else is still buried beneath the ruins, waiting to be discovered? The ancient world has already shown us that history is far more complicated than we once believed, and maybe the greatest ancient technology isn't the one we've already found. Maybe it's the one we haven't discovered yet, because somewhere beneath the ground, at the bottom of the sea, or hidden inside ruins, there may still be inventions that could completely change what we think we know about the past. And when we finally uncover them, we may discover that history still has a few secrets left to surprise us.